Hello everyone. In the previous class, we spoke about what acids and bases were, what the pH scale was, indicators, and how we have acids and bases in everyday life. Today, we'll speak more about the chemical properties, that is, the reactions of acids and bases with various other substances. First and foremost, what do acids and bases have in common? Well, in the last class I mentioned that acids give you H3O plus ions in solution. The same way, bases give you OH minus ions in solution. So what this means is, if you were to take a container, fill it with water, and dip in a couple of electrodes in there, connect that to a battery and a bulb. Well, this is just a simple setup to see whether the solution is conductive or not. Now, if the solution is water, if this is just H2O, then that is distilled water or deionized water, then no light. The bulb does not glow. Alright? But if it is an acid or a base, any acid or base, the bulb will light up. Alright? So the bulb glows. That shows that current can pass through the solution. That is because of these ions. Alright? Ions can conduct solution. Pure water, distilled water, does not have any ions, or does not have many ions. So that does not conduct as well as an acid or a base solution. Now, many substances, when dissolved in water, do conduct electricity. Those are called electrolytes. They could be salts, acids, or bases. But many of the other compounds, like alcohols or glucose or things like that, that are organic in nature, they do not have any ions. So for conduction to work, for a solution to conduct electricity, ions must be produced. Therefore, acids, bases, and salts conduct electricity, whereas alcohols, glucose, etc., sugar, do not conduct electricity in solution. Alright? So acids and bases, what they have in common is ions. They can ionize, and the ions they produce will give you currents in a solution like this, in an experiment like this. Alright? So now let's look at some of the reactions of acids and bases. The first one here is acids and bases with metals. Now, one of the first examples I gave you in the previous lecture was what happens when you drop zinc into dilute hydrochloric acid. All right. So zinc in hydrochloric acid gives you zinc chloride plus hydrogen gas. All right. Now let's just balance this. So zinc in hydrochloric acid will give you zinc chloride and hydrogen gas. So what is this? This is a metal. This is an acid. This is a salt. And this is hydrogen gas. All right. So in other words, we can say acid plus metal will give you salt plus hydrogen gas. All right. Now, if you want to know exactly how this happens, you can check out link 1 in the description where they put zinc in hydrochloric acid. All right. Now, what happens when a base reacts with a metal? Something very similar. All right. So think about a base. Let's take zinc metal again. Let us take sodium hydroxide instead. We get hydrogen, but another different kind of compound. You can call it a salt, but it is not a normal salt. It is a basic salt. You can think about it like Na2ZnO2. Now this, okay, we need to balance this first. Okay, that should do it. What are these? So this is a base. This is hydrogen gas again. This is a metal. And this here, very important, is a basic salt. All right. So, but just one thing, this may not work with all metals. It works with some metals it doesn't. Aluminium it works, zinc it works, but sometimes it does, sometimes it doesn't. But in general, you can say that a metal can react with a base and still produce hydrogen in a way very similar to a metal reacting with an acid to produce hydrogen. All right. If you want to know more about this, look up link 2 in the description where they test various metals in sodium hydroxide. Okay. Now, let's look at another kind of reaction. Reactions with carbonates or hydrogen carbonates. Now, carbonates are salts of carbonic acid. Carbonic acid is H2CO3. So, a carbonate is Na2CO3 or something like that. Any salt of carbonic acid. Whereas a hydrogen carbonate, also known as a bicarbonate, is a sodium salt that is not completely neutralized. So it will be like NaHCO3 or KHCO3. So the presence of this hydrogen, this ion is HCO3 minus. This is a CO3 minus ion. This is a CO3 2 minus ion. All right, just so that you know. So these salts can react with an acid to produce carbon dioxide gas and water. All right, how does that work? Let's try, say, sodium carbonate, Na2CO3 plus a strong acid, say HCl, will give you NaCl, sure, CO2, sure, H2O. Now, how do we balance this? We have 2 sodiums here, so this has to be 2, and then 2 chlorines to match it. All right, so that does it. What is happening over here? We have a carbonate reacting with an acid to give carbon dioxide gas and water. Now this happens even with a bicarbonate, all right, or a metal hydrogen carbonate. That would be like NaHCO3 over here. The balancing will be different, but the products will pretty much be the same. Okay? There's not going to be much difference there. So either a carbonate or a bicarbonate will produce CO2 when reacted with an acid. Alright? Now you want to see this more? Look up link 3, where someone puts carbonate and acid and then they capture that carbon dioxide and test it using lime water. So it's a simple reaction. When you pass carbon dioxide into lime water, you will get calcium carbonate and water. Now this calcium carbonate is a white precipitate. This is colorless. And this is a gas. So again colorless. So this reaction, if you pass carbon dioxide into lime water, you get a milky white precipitate, which is calcium carbonate. So if calcium carbonate is formed, you know the gas produces carbon dioxide. This is also there in the video. You can take a look at it. Alright? Okay. So now we spoke about how metals and carbonates react with acids and bases. Let us see what happens when acids and bases react with each other. Acids plus bases will always give you salt plus water. This is something you should remember. Alright? It is very straightforward. I'll show you how that happens. Let's take an acid, say hydrochloric acid, and a strong base, say sodium hydroxide. We get, we get NaCl plus H2O. Now how does this happen? This has to be in water. There has to be a solvent for all this to happen. So in a solvent, HCl is H plus Cl minus. The same way, NaOH is Na plus OH minus. Now what you need to understand is the H plus and the OH minus react with each other to give you water, and the other two ions, that is the ones that are not the H plus or the OH minus, react to give you a salt. So no matter what acid and what base you react, you will always get water. The salt that you get depends on which particular acid or base you reacted to get there. Okay? So that is the simplest part. Any acid, any base, you will get salt and water. Say H2SO4, this is sulfuric acid, plus sodium hydroxide will give you sodium sulfate plus water. Always. Alright? So this is it for acids and bases, and these are always salts. This is a salt. And water, of course. Let's balance that. Yes. So now that we're done, what about oxides? Alright? Metallic oxides plus acid. Now what kind of a reaction is a metallic oxide with an acid? So firstly, you have to know that metallic oxides are usually basic in nature. I'll write that down. Metallic oxides are usually basic in nature. Alright? So if it is a base, if it behaves like a base, you would expect that a base plus an acid will give you at least a salt and water. So you can say metallic oxides plus acids will give you salts plus water. as expected. Let me give you an example. Let's take a simple example. Let's take FeO, iron 2 oxide, plus an acid, HCl, 2HCl. We will get FeCl2 plus H2O or something similar, right? Any of these is possible. It's just any metallic oxide you take, you will get a salt and water. So FeCl2 is a salt, iron 2 chloride, this is water, and FeO is iron oxide, this is a metallic oxide. In a very similar fashion, think about a non-metallic oxide. So we know that non-metallic oxides are generally acidic. Okay, so non-metallic oxide plus base will also give you salt and water. Okay, we just saw an example right here, right? Carbon dioxide is a non-metallic oxide because carbon is not a metal. Calcium hydroxide is a base. Calcium carbonate is a salt, and this is water. So how do we get this? We can try another example if you like. Say CO2 plus NaOH. Now in water, CO2 behaves like H2CO3. Alright. Now H2CO3 plus NaOH is a very simple example. How would that work? We'll give you Na2CO3 plus H2O. Why did I write 2? I don't know. So that's how it works. So this is what happens. Any non-metallic oxide, it need not be just carbon, it could be sulfur, it could be any of the other non-metals. They will give you a salt plus water always. Okay, so with this we've covered the reactions of acids and bases with themselves, with metals, with metallic oxides, with non-metallic oxides, and the reaction of acids with carbonates. We'll stop here. In the next class, you will learn a little more about salts. Thank you.